Today we are learning about geometric probability. Please copy the standard benchmark indicator on a clean page in your math notebook. The student will predict the probability of outcomes of simple experiments and do the experiment. Geometric models of probability. Some events and outcomes are not always single items that can be counted. For situations such as carnival games and dartboards, the probability of an event happening depends upon the areas of portions of a figure. If you can determine each area within the figure, you can determine the probability of the situation. Example, a carnival game has a dartboard with a pattern like the one to the right. What is the probability of hitting a shaded square? There are 30 square units in the rectangle. 18 of them are shaded. The probability of hitting a shaded square is 18/30ths, or once we simplify it, 3/5. Try it. Use the game board to find each probability. What is the probability of a marker landing on the letter W? Well, if we look, we can tell we have 16 squares here, and we're going to go through and circle the W's to make sure we have all of them. As you can see, we have 4 W's out of 16 possible squares. So our probability is 4/16. We know we always need to simplify, so we're going to divide the top and the bottom of the fraction by 4 and get 1/4. Next, B asks, what is the probability of the marker landing on the letter O? So next thing we're going to do is take a different color and we're going to circle the O's we find. As we can see, there are 3 O's, which gives us a probability of 3/16, which we know cannot simplify. C asks, what is the probability of a marker landing on the letter R? So we're going to take a different color and we're going to circle all the R's. As we can see, there are 5 R's on here, so the probability of landing on an R is 5/16, which again cannot simplify. Finally, for D, what is the probability of a marker landing on the letter D? We're going to go circle the D's and then write out our fraction. And for this, we get 4/16, which again will simplify to 1/4. Suppose you drop a token on each sheet. Find the probability of the token landing on the shaded area. For E, we have a circle, and we can tell that our circle has been broken up into 7 equal sections. 3 of them are shaded, so our fraction probability is 3/7. For F, we have 8 sections. 4 of them are shaded, so our probability is 4/8, which simplifies to 1/2. For G, we have 6 sections. 2 of them are shaded, so we have 2/6, which equals 1/3. A skydiver jumps out of a plane above an area represented by the map to the right. H asks what is the probability the skydiver will land in water, and I wants to know what's the probability it will land on land. So the first thing we need to look at is we can tell we have 16 squares. Now, we have a number of squares that are partially covered, and we have to figure out how to work with those. So what we're going to have to do to get these to full squares is we're going to have to mentally move some pieces to fill in so that we have whole squares instead of partially shaded ones. So the first thing we're going to do is we're going to take the top water partially shaded square, and if you look, that will exactly fill the bottom left. So we're going to cross that out and shade in the bottom left as water. Now, the tiny little piece of shaded water on the second row that's left will fill in that tiny little open space on the bottom. So again, we're going to cross out the little shaded spot, shade in the bottom. So we're moving pieces to make whole squares here. Now we're left with the two squares in the middle of row 3. And again, the little shaded spot on the left square will fill in the white spot on the right square. So again, we're going to move some pieces here. So now we're going to go through and number the squares that are now completely land. So now we've got 10 land squares and 6 water squares. So the probability the skydiver will land in water is 6 out of 16, which simplifies, becomes 3/8. Then for I, what's the probability he'll land on land? We now have 10 land squares out of 16, which simplifies to 5/8. So while it's close, he's slightly more likely to land on land than he is on water. Please make sure you have all of the work copied down and glue this page in your math notebook.